I don't know.
Hey Caitlin, what's up?
Y'all are all over there.
Yeah, that's fine. Just make sure you put a paper towel over it.
She had like against Tony.
Okay, are y'all ready? Your notes today are pretty easy, okay, so, huh? Oh, easy. Okay, so do you remember last class we were solving with common bases, but the first thing we looked at was the graph. So we're gonna just review that real quick. So take a look at number 1. Okay, an exponential function we said was 2 to the x. And do you remember this was your exponential growth and it had a horizontal asymptote? So the asymptote is going to be y equals 0 and it ran this way. And then remember that since you can't touch 0, this parent graph can't go through the origin. So do you remember it hits one box above the origin? So it's going to hit right here. And then do you remember your growth graph is going to get bigger as you go to the right, and then it's going to kind of flatten out as you go to the left. So it's going to get bigger on this side and flatten out on this side. Okay, that's your exponential growth parent graph. Then we talked about all the different ways you can kind of shift it to the left, shift it to the right, up, down, whatever. What is your domain for this graph? Do you remember? Okay, all real numbers. Because you have arrows on both sides. And then for the range, what is the lowest this graph can go? 0. What's the highest? And will it ever get to 0 or infinity? So we use parentheses. Okay, so now we're going to take what we know about exponentials and we're going to talk about their inverse, which is called a logarithm. Okay, so the inverse of an exponential is called a logarithm. Okay, and the parent function is going to be y equals log x. Now, because it's an inverse, there are some automatic things that we know. The first one is that remember your x and your y for inverses are always flip-flopped, right? Thank you. So if your original asymptote was y equals 0, I'm going to change that to x equals 0 for a logarithm. Which means that now, instead of my asymptote running this way, now it's going to run this way. So keep it at 0, but draw your dotted line in this way. And then instead of placing your one marker dot, one above, you're going to place it one to the side. Now remember, for exponential growth, your graph is growing faster and faster and faster. For a logarithm, that's going to be the opposite. It's going to start off really steep and then flatten out sort of to the side. And then your asymptote going down, it's going to get closer and closer to that line. But remember, since it's an asymptote, it can never actually touch it. So it's going to kind of look like that. So this is your exponential graph up here. And this is your logarithm graph down here. Okay. Then for your domain for this one, will you just look at that graph we just did? Will my domain still be all real numbers? For this one? Can it go to the left forever? No, because it gets cut off where?
0.
At 0. So your domain is now restricted, that I can't go past 0. And not only can I not go past 0, but I can't touch 0. So I'm going to give it a parenthesis. But now what about my range? Now my range is all real numbers. So I want you to compare that to the domain and range for the original. What do you notice about the domain and range here? They're reversed. Because why? Because if you switch the x and the y, the original domain becomes the new range. And the original range is becoming the new domain. One more thing. What is this dot right here as an ordered pair?
0, 1.
0, 1. And what is the marker dot on the inverse?
1, 0.
Okay, and you should know that that makes sense, that if these are inverses, that relationship should be like that. Okay, the other thing that you should remember from the unit that we did on inverses is that, do you remember they were always like a reflection across the diagonal? So if I were to take my exponential graph and put it on top here, so go to 0, 1, you don't have to do this, you can just watch if you want to. Okay, and then I go this way and then this way. Do you see how that diagonal is going to cut your picture in half? Just like when we did that whole unit on inverses. Okay, so logarithms are the inverse for exponentials. So let's do a couple of graphs. These should be pretty easy because all of your rules stay the same. If I have a -3, which way do I shift? Left, right, up, down. To the right 3. What about the +2? Up. So I'm going to go to the right 3 and then up 2. So 3, 2. But remember, this is a log graph. So I'm going to have a vertical asymptote through that dot. Just like this. And then my marker dot goes exactly 1 dot to the side. And then remember, your graph grows away as you go up and towards as you go down. What would the equation be for that asymptote, that dotted line that I drew? X equals what? 3. So notice moving it up or down won't adjust the asymptote, but the side to side shift, that'll adjust where your X equals for your asymptote. Okay, take a look at one more of those. Look at number 2. I have a +5. Which way are we going? To the left, and -1, we're going down. So left 5, down 1 is here. And then remember, logs get a vertical asymptote. You can kind of remember that because like logs come from trees and trees are up and down. Okay, so there's your log asymptote. And then remember, my marker dot needs to go 1 to the side of that to be right here. And then I'm going to go up and away, down and towards, just like that. What would my asymptote equation be? X equals what? -5 because we shifted it to the left side. Pretty easy? Okay, go ahead and turn the page. So logarithms, have y'all done these in other classes?
Like geometry.
I don't remember. Oh, in geometry?
I think we did something with that. I think we did, I swear.
Really? Okay.
I
These,
remember the word logarithm.
you do? From geometry?
I think so.
Wow. Oh, wait. Y'all do rule? I don't know.
Like,
Tell me if this looks familiar.
No,
because I'm
log-
curious.
Maybe I wasn't on ramp, so maybe.
In algebra 2, it would make sense.
Oh, yeah.
Oh no, I had logarithmic in pre-calc, and I was in pre-calc on ramps.
Oh, for honors. All right, so logs, here's the thing about logs. They only have 3 properties and they're all kind of weird, but they're not hard. So for the first property, I want you to put that if you have the log of 2 things that are multiplied, so let's say A times B, and they're in the same log, you're allowed to separate that into 2 separate logs using addition. So I would write that as the log of A plus the log of B. So product, you can split using addition. The second property is for division. So put log A divided by B. Okay, now let's logically take a guess. If multiplied things split with addition into their own logs, what do you guess divided things will split using? Subtraction is correct. So I'm going to do log A on top minus log B. So take a look at number 3. Okay, I have a log and it says to expand. Expand means that none of the numbers or letters are sharing the same log. So I have log 8x. How are 8 and x combined? Are they multiplied or divided? That is 8 times x, which is multiplication. Then how will I separate multiplication? I'll use oop, plus or addition, yeah. So I'm gonna do log 8 plus log x, and you're done. Now take a look at number 4. I have an 8 and an x in the same log, but how are they combined here? That's division. That's 8 divided by x. So when I separate them each into their own logs, will I use addition or subtraction? So it would be log 8 minus log x. We understand the difference there? Okay, now for number 5, you'll notice that I have 3 things in that log. What are the 3 things in the log? I have a number, what is it? 2, and then I have an x and a y. So let's break down what the operations are first. I have a 2 multiplied by an x, and then divided by a y. So I need to split that into 3 separate logs. So I'm going to have log 2 first. Will I add or subtract x's log? Because x is multiplied. Okay, so add is correct. Will I add or subtract y's log? Subtract. Okay, easy? Okay, there's only one more rule. Okay, the last one is the exponent log property. Okay, if you had the log of something with an exponent on it. So let's say it's x to the n, where n is some power, like maybe a squared or a cubed. Okay, you are allowed only within logs to just move the number to the front.
Wait,
So it would be n log x. Very stupid rule, but it is a rule within logs. That you can just take the exponent and just load it down to the front. Okay, and there's only 3 rules. You just learned the 3rd one. So let's take a look at number 6. Okay, first thing we want to do is count how many logs we're separating into. So I have a 2, an x, and a y. How are they all combined with multiplication or division? They're all multiplied. That's a 2 times an x times a y to the 5. So when I break it down, I'm going to have a log 2 plus or minus plus log x plus or minus plus log y to the 5. Okay, everybody looking at that? Does that make sense? Okay, then the worst rule of all, this little 5 can just and go right there. So now here's your final answer. It'd be log 2 plus log x plus, and then the 5 down to the front is now 5 log y.
So it just can go to the right in front of it.
It only goes in front of the log that it was a part of, correct? So kind of weird, but let's do another one and see if we can kind of get the hang of it. So take a look at number 7. How many logs am I splitting number 7 up into? 3. I'm going to have an x, a y, and a z. How are they all combined? Multiplication or division? A multiplication. So that's an x3 times a y times a z7. So every one of those letters should end up getting its own log. So I'm going to have a log x3 plus a log y plus a log z7. it is not considered fully expanded until you take those exponents and drop them down to the front. It's just a rule with logs. So what numbers am I moving?
3 and 7.
And 3 will go to the front of X's log. And 7 will go to the front of Z's log. So it would be 3 log X. My log Y stays the same. And then, oops, that's not 7. And then 7 log Z. Okay, how we doing? Weird but easy, hopefully. Okay, one more example, take a look at number 8. Is, am I gonna have multiplication, division, or a mix of both? You're gonna have a mix of both. Now I want you to break down what the operations are in here. So I have it 2. Is it multiplied or divided with the A? So it's multiplied by A3. What about the 2 compared to the 7? The 7 is divided. Now be careful, listen to how I'm asking the question. 2 is the first thing. 2 is multiplied by A. 2 is divided by 7. How is 2 related to B? Look where 2 is, look where B is. That's still a divide because it's where in the fraction in the bottom. So this is also a divide on the B5. Now, someone in second period was like, wait, aren't the 7 and the B multiplied together? Yes, they are, but they're multiplied together where? In the denominator. So they're both being divided with 2. You can multiply them together first, but then you're going to have to divide by that. So both of those count as division. Okay, so we're going to have 4 logs. Let's see if we can write the answer in just one step. So what would I write first? Log
2.
Okay, log 2 plus or minus plus 3 in the front, log A. And why is the 3 in the front? Because it was an exponent and it just down to the front. Next one, log 7's coming up, plus or minus. Minus log 7, plus or minus log B. Minus 5 log B. So those exponents originally were up top, but we're moving them to the bottom based on that property number 3. Does that all make sense?
Yeah.
Okay, turn the page. Okay, one last thing to cover. What if you get a square root or a cube root? So turn the page, please. Okay, if you get a square root, turn the page. What exponent is the same as a square root? Okay, yes, it does have to be on the letter. Do we know what power? So 2 is squared. So square root is 1/2. Okay, so maybe I didn't ask that question well. But if it's a square root, that's the same as that same base to the 1/2 power. Now, if a square root is a 1/2 power, what do you think a cubic root is? What fraction? 1/3. Now, you could do this with any type of root, but the only ones that show up on your practice are square roots and cubic roots. So what if I had a 5th root? What would that be? B to the 1/5. Does that make sense? So basically, whatever your index of your root is, that's the denominator of the fraction you would use as an exponent. Okay, so now let's take a look at number 10. Yes?
Give me that.
Yes. So take a look at number 10. I have a 7 and a root x. How are they related? Multiplication or division. That's a 7 times a root x. Then when I split them up, will I use addition or subtraction? Addition. So it'll be log 7 plus log root x. And then I would say, wait, I can't leave the x in the root because a root is really a hidden power. What power is it? A 1/2. So I would have to then eliminate this square root by using a 1/2. And then move it down to the front. Okay, so then this would move down here. So my final answer would be log 7 plus what?
1/2 log.
There we go, 1/2 log x. Good there? All right, let's skip 12 or 11, let's go to number 12. How many logs are we separating number 12 into? How many pieces do you see? 3. I have a 5, I have an A, and I have a B. So what are the operations between those? Start with 5. Is 5 multiplied by a squared or divided by a squared? Multiplied, and then how is it related to cubic root B? It is divided by cubic root B. So then when I separate, the first 2 logs will get addition between them, but the B log will get what? It'll get a minus. So I'll have this log 5 plus log a squared minus log cubic root B. Okay, I would scan over that. Everybody's in their own log, but I still see exponents, and that's not allowed. Also remember that roots are hidden exponents. So if I have a cubic root, what exponent is that really? That's really, cross it out, a 1/3. Good job, Anaya, that's right. And then from there, I'm gonna take those numbers, drop them down to the front. So my 2 is gonna end up in front of my log A. My 1/3 is gonna end up in front of my log B. So your final answer would be log 5 plus 2 log A minus 1/3 log B. Hard, easy, how do you feel? Easy, okay. 2 more examples left, then we're in the first part of your practice. Okay, take a look at number 13. How many logs are we separating into? 3. I'm gonna have a 10, an X, and a Y. So I'm gonna have log 10 plus or minus. Plus log square root X 5 plus or minus. Plus log cubic root Y 4. Okay, from here, remember that square roots are really hidden powers of what? What's a square root the same as? What fraction? Half or a third? Okay, so put a half here. Why grab a seat and I'll get your test in a second. And then what about my cubic root here? What's that fraction gonna be?
1/3.
1/3. Okay, here's what I want you to do though. If there's already a power, I just want you to smush it together into one single power. Thank you. So if I have a 5 and I want to cut it in half, is that the same as 5 halves?
Yeah.
And then drop it down together. So this is gonna combine to be log 10 plus 5 halves log x. See if that makes sense, because the half on 5 is 5 to cut in half.
You don't change the denominator.
You do not change the denominator, that's correct. Okay, same thing for the 4. What do I want to do with the 4? I want to cut it into thirds. Well, then that's the same as 4/3 log y. Does that make sense? Okay. Last example. Take a look at number 14. How many bases do you see to separate into logs?
3.
Still 3. I have a 2, a C, and a D. So I'm gonna have log 2 plus or minus plus log C plus or minus plus log D to the 4. All of those were inside the cubic root, right? So that means that all of them need to share what power? 1/3. So I'm gonna put a 1/3 all the way across on every letter that was inside the cubic root. So I'm gonna put a 1/3 here, here, and here. And then if your third is hitting another number, you'll combine it. But if not, you can just drop it down to the front. So what will my first log say? Once I move it, 1/3 log 2, yeah? Because 2 in this case is a base. So you can't combine it with the third because the 2 is the base. Okay, then next one, what would it be? 1/3 log C. And then for the last one, what would it say? 4/3 log. Does that make sense? Okay. So you'll notice you still have 1 page of notes. That's just the same rules going backwards. So we're gonna take a little break, work on your homework for a bit, so pull out your Chromebook. Okay, you are only expanding logs right now. Don't do any condensing because we haven't covered that. Okay, only expanding. You're gonna equate the fraction, you'll put stuff probably above that. Remember, you're using all the same equation and your answer. This is the form for the and then it's.
Who's the coldest death?
This one's like.
EJ? Yours? Who's the crashes? Who's the most mediocre?
And then where's your office? And then. You have anything on the last page? You have equation, no, it's not amazing, the whole.
Not even in it.
And then.
No, he doesn't smile.
I don't know, I'm never. I mean, of course, it's done. Okay. Would you like a calculator? And then I'll take your, Mr. Okay. Oh, okay, that's fine. Yes. Sure. On last times. Okay, even if you're not finished, that's okay. Just turn to that last page for me, please. Since a lot of people are ready to condense. The good news is that remember, it's the same 3 rules. Okay, but what you're doing on the back page is you're gonna go from multiple logs, like breaking it back into just 1 log. Okay, so take a look at that last page. This will just take a sec. Okay, if you have 2 logs that are added, how would you put them back together? You would multiply. So you would put them into the same log, but do A times B. We're just starting that last page. Okay, what if A and B originally were in logs that were subtracted? How would I put it back together? You would divide, so they'd go back into the same log, but it'd be A divide by B. Now make notice of the fact that your first log stays on top. The minus log is the one that divides under. Okay, and then your last rule, if you have a number in the front of a log, just like that number can kind of float down to the front, now we're gonna float it up from the front. So this n here is gonna end up going whoop up here to be log A up to the n. Okay, that is supposed to be an n, sorry. Okay, but you are going to do these steps in the reverse order that you do them in for expanding. So what I mean by that is that I'm going to start off by pulling exponents up. So in number 1, what number can be pulled up as an exponent? The 7. So I'm going to take the 7 and I'm just going to move it up top. Now that's an x to the 7. Okay, then from there, I have 2 logs that are added. How can I combine them? You're gonna multiply the 3 and the x7. So it'll be log 3x7. Okay. Let's skip number 2, go down to number 3. What numbers can move up as exponents? Okay, the 10 can go up to be an x to the 10th. And the 5 can move up to be a y to the 5th. Okay, from there, I'm going to package all of that back together into the same log. So I'm going to have log, parentheses. The 14 is added with the x log. How will I put those together? 14x10 over what?
5.
y5, yes. Yes, that's right. Okay, but just think about term by term. If it had a plus, it stays on the top. Anything that was minus would need to go to the bottom. Now, take a look at number 4. Number 4, before I do anything, I'm going to deal with these parentheses here. Okay, those parentheses tell me that I need to distribute. What am I going to distribute on number 4? The subtraction here. So that's going to be a log x minus a 5 log a. And then what happens when I minus on the 3 log b? Now it's a subtract 3 log b. Okay, so eliminate your parentheses first. Then follow the same steps. Which of those numbers can move up? Okay, the 5 is now an a to the 5th. The 3 is now a b cubed. And then from there, when I repackage that back into one log, how many things will end up on top? Only one. Which letter ends up on top? The x. And on bottom, what am I going to have? A5b cubed. Okay, but if you look at it originally, you might have thought, well, oh, the b's added, so it's going to be on top. Okay, wrong, because of that subtraction being distributed. So just be a little bit careful about that. Does that make sense? Okay, one more like that. Take a look at number 5. Okay, we have distribution again on this one. So I'm going to do 4 multiplied in. Thank you. If I think you should be in B209. You're in C209. Sorry. That's okay. So that's now going to be 4 log x. What will the next number be? 4 times 8 is, yep, 32 log y. Now you'll notice there's a weird little 5 there. That shouldn't be there. Just cross that out. We're going to get to that number next time. So if you want to just eliminate those little 5s, ignore those for today. They're not in your practice. So I have 4 log x plus 32 log y, and then minus 2 log z. And then from there, those exponents are gonna pull up top and then I'll condense. So my 4 is now an x to the 4. My 32 is now a y to the 32. And then my 2 is now a z squared. When I package that all together, how many things will end up on top this time?
X4.
Yes, and y 32. So I'll have x4, y 32, and on bottom I'll have a z squared. That kind of makes sense? So it's the exact same rules, you have the opposite goal. Now you're trying to put them all back together. Okay, last two things. Remember, a 1/2 and a square root are the same, 1/3 and a cubic root are the same. So let's take a look at number 9. Do we have parentheses?
Yeah.
Then we have to do that first. So I'm going to bring the 1/2 in. What is a 1/2 times 6 log A? 3 log A. And then what is a 1/2 times log B? 1/2 log B, right? So if there's nothing in front, I'll just put the 1/2 there. But if it's 1/2 of like 6, then do it. You know what I mean? Okay, from there, we're gonna pull those exponents up. So my 3 is now an A cubed. And my B is now a B to the 1/2. But wait, what is a 1/2 power the same as? Square root. So I'm gonna now rewrite this as log A3 plus log root B. Because we know that a square root and a 1/2 power are the same. Then from there, I have 2 separate logs. I want to bring them back together. How can I condense into the same log? Will I use multiplication or division? Multiplication, because originally it was addition. So it'd be A3 root B. But they would now be in the same log. Make sense? Okay, last example. I have a 1/3 on the outside. Remember, if there's a number there, a 1/3 means divide by 3. So if I have a 1/3 of 12 log A, a 1/3 means divide by 3. So what is 12 if I divide it by 3? That's a 4 log A. And then minus a 1/3 on my log B, there's nothing in front, so I'll just keep the 1/3 there. And then minus a 1/2 log C. Then I'm going to take all those numbers and pull them up, but I'm going to pay attention to the fact that any fraction can swap back for a root. So my 4 is now an A to the 4th. My 1/3 is now a B to the 3rd. And my 1/2 is now a C to the 1/2. But then remember, those radicals need to come back for simplified form or condensed form. So I'm going to show the extra step, but you may not have to, it's up to you. This is still a log A4, but what happens to my B? Now it's a cubic root B. And then what happens to my C? Now it's in a square root. And then once I swap those back for roots, now I put everybody back together sharing the same log. So how many things will end up on top? Just the A4. And then on bottom, I'll have the cubic root B and I'll have the square root C. Okie dokie. All right, so we'll connect this lesson to next class to what we were doing before. But for now, it just seemed like a bunch of foolish rules. But do your best. You can do it.